Dear math aspirants, right now I have the mathematics book and figure 13.2 will provide you the information regarding limits and derivatives comes under mathematics. And here the limits, the discussion about limits clearly points towards the discussion about limits clearly points towards the fact that we need to understand limiting process in greater clarity. We study a few illustrative examples to gain some familiarity concept with the concept of limits. Consider the function f(x) is equal to x square. Observe that x takes value very close to the value of f(x) also moves towards 0. We will get into 2.10 chapter figure 2.10 chapter 2, but this is another chapter. We say limit x tend to 0 fx is equal to 0 to be read as limit of fx as x tends to 0 equals 0. The limit of fx as x tends to 0 is to be thought of as value of fx should assume at x is equal to 0. In general, as axes tend to a, fx tend to l, then l is called the limit of the function fx, which is symbolically written as limit x tend to a, fx is equal to l. Consider the following function gx is equal to x. X is not equal to 0. Observe that go 0. G is not defined. Computing the value of gx for value of x very near to 0, we see that value of gx moves towards 0. So limit x tend to 0 g all x is equal to 0. This is intuitively clear from graph of y and lx for x is not equal to 0. See figure 2.13 chapter 2. You will see here figure 2.13 of relations and functions of mathematics. You will see here, and the modulus function you will see here. You will see here the G.W. Leibniz 1646-1716. The much of mathematics is about finding a pattern, a recognizable link between quantities that change in our daily life. We come across many patterns that G.W. Leibniz 1646-1716. In this chapter, we will learn how to link pairs of objects from two sets and then introduce relations between the two objects in the pair. Finally, we will learn about special relations which will qualify to be functions. The concept of function is very important in mathematics since it captures the idea of mathematically precise correspondence between one quantity with the others. Consider the following function gx x not equal to 0. Observe the g0 is not defined. Computing the value of gx for values of x very near to 0, we see that value of gx moves towards 0. So limit x tend to 0 gx is equal to 0. This intuitively clear form of the graph of y is equal to x for x is not equal to 0. See 2.13 chapter 2.13 chapter what you have seen before sometimes. Consider the following function h whole x is equal to x square minus 4 by x minus 2. X not equal to 2. X is not equal to. Compute the value of hx for value of x very near to 2, but at here you will see. Convince yourself that all these values near are near to 4. This is somewhat strengthened by considering the graph of the function y is equal to f h all x given here 30.13.2. Here you will see 13.3. In all these illustrations, the value of which function should assume at given points xi did not really depend on how x tending to a. Note that there are essentially two ways of x could approach the number a, either from left to from right, i.e. all the values of x near a could be less than a or could be greater than a. This naturally leads to the two limits, the right hand limit and left hand limit. Right hand limit of function fx is value of fx, which is dictated by the value of fx when x tends to a from the right. Similarly, the left hand limit, to illustrate this, consider the function fx. Here graph of this function shown in figure 13.3. You will see here it is clear that the value of f is 0 dictated by value of x with x is less than 0 equals i.e. left hand limit of fx 0 and limit fx to 1 x tend to 0. Similarly, the value the fx of 0 and 0 dictated the value of x fx with x greater than 0 equals 2, i.e. the right hand limit of fx at 0 is extend to 0 limit fx 2. In this case, the right and left hand limits are different, and hence we say that the limit of fx as x tends to 0 does not exist even though the function is defined at 0. Thank you very much for watching this video.